Hi and welcome. In this project we're going to deploy using a Flask API the TensorFlow Estimator breast cancer machine learning model we created in a previous video. The link to that video is below. We'll then develop this website where a user can submit breast cancer measurements, click the predict button, and the model will return the probability that the measurements represent a benign or malignant condition. So let's get started. We're going to look at all the code required to deploy a machine learning model as a web service, but let's start with a summary. This graphic gives us a summary of how we can deploy a trained machine learning model using a web service API. This web page is index.html. When a user clicks the predict button, the JavaScript code in index_bc.js reads all the measurements from the input text boxes and sends them over the internet in JSON format to predict_bc.php via an HTTP post operation using AJAX. In predict_bc.php, we extract the measurement values and use curl to post the data to the Flask web server. The Flask web server receives the cancer measurements and runs the Estimator API predict function on the data using the machine learning model saved_model.pb. The model returns the probabilities that the data belongs to each category, either benign or malignant. In flask_server.py, the probabilities are JSON encoded and returned to the curl function in predict_bc.php, which is then returned to the AJAX function in index_bc.js. In index_bc.js, the JSON formatted probabilities are parsed and assigned to the inner HTML of a span to display on the web page. So let's take a look at the code. All the code is available at the GitHub link below. I won't go through all the HTML code, but rather point out the important parts that are required for this project. We need to reference our index_bc.js file, as it contains our JavaScript code to read the cancer measurements and post the data. You also need jQuery for the AJAX functionality. We call the page load JavaScript function when the page loads, which gets all the elements we need to get values from or assign values to. Here we assign IDs to the input text boxes so we can read the values from JavaScript, and here we define the JavaScript function that will run when the user clicks the predict button. And here we assign the IDs to the spans that will display the probabilities that are returned from our model. The user can also preload benign or malignant data when they click these buttons. In the index.js file, when index.html loads, page load is fired, which gets a reference to all the HTML elements we need to read values from or assign values to. These are our text inputs, and these are the spans where we display the probabilities. When the user clicks the Load Benign button, these values are loaded in the input boxes. When someone clicks the Load Malignant button, these values are loaded. The AJAX operation is the heart of the predict function. Here we define the AJAX operation, in our case a post operation. The URL we want to post the data to, the data type will be JSON format, and the actual JSON data. That is the label and the value pairs. When the operation is complete, it will either be successful or error. If it's successful, we run this function. First, we write the server response to the console so we can see what's going on. And then we parse the JSON response so we can get the individual values, and we display this in the console as well. This is not necessary for the functionality of the website, but it helps in the development process. So for example, if we take a look at the console, we see the server's response when we click the predict button. Here is the raw JSON response, and here are the parsed values. Then we cast the text JSON probabilities to a float, multiply that value by 100 to convert it to a percentage, and display it to 1 decimal point. Note that it is possible that the AJAX function is successful, but an error is generated on the server. We test for that case with the try catch statement and print error in the results if that happens. If the AJAX operation is not successful, we display the word error for the prediction. In predict.php, we import IP_address.php, which contains one variable, $IP_address, which is the IP address of our Flask server. We then retrieve the cancer measurements and assign them to variables. We create an array of variables and values and JSON encode this array so we can send it out to our Flask server. We also create a header with the content type of application/JSON. We create variable $URL, which is the IP address from IP_address.php, the port of the Flask server, and the app route. Next, we initialize a curl instance and specify the URL of the Flask server. The operation type, in our case, a post operation, the header, and a few other settings. The most important are the fields we want to post in our payload variable. We then execute the curl operation, and the results returned will be the JSON encoded prediction values, which we echo back to the JavaScript function. Running on the server is our Flask web server. A few things that are important. We import our custom library IP_address, which contains one variable, IP_address, which is the IP address of the server. When we run the script, we load the Keras model for our previous projects as well as the saved_model.pb for this project. We then start the Flask server running at the IP address specified in the IP address library, listening on port 5000. The server is listening for an app route request of /BC/API, and it's expecting a post operation. Here we get the posted JSON data and then parse it into the predict_request array. The model we created earlier using TensorFlow Estimator API requires serialized strings of input data. The simplest way to accomplish this is to create a pandas data frame and iterate over the rows to create the data array. It seems like there should be an easier way to do that, but that's my understanding from the Estimator API documentation and examples. Note that this allows for the pandas data frame to be an array of inputs. See the breastcancer.ipynb Jupyter Notebook for how this works. We then submit the data to the predict function, which runs the inference on the data using the model we loaded earlier. The predict function returns an array called predictions, which contains the scores, which are the probabilities for benign at 0, 0 and malignant at 0, 1. We JSON encode this array and return it to the PHP function. From there, as we've already covered, the PHP script echoes the predictions back to the JavaScript AJAX function, and if successful, the data is parsed and displayed on the web page. So there you have it. In this video, we deployed a previously trained TensorFlow Estimator API machine learning model using a Flask API. I hope you found this video useful. If you did, please subscribe, and if you think this video might be helpful to someone else, please share. Also, the code is available at the GitHub link below. If you have any questions, post them below and I'll try to answer them. And also, if there are any topics you'd like to see a video on, post that also in the comments below, and thanks for watching.